Okay, the second part of today's activities will include learning how to work with an acceleration graph. Okay, what you're going to be doing here is you're going to follow this line from A to B, B to C, C to D, D to E, E to F, F to G, and finally G to H. What you're going to do for me then is calculate the acceleration from one point to the next, and then describe for me the motion. Okay, and then after doing that, you should realize that anytime you see the graph moving upward, you're going to have a positive acceleration and increase in velocity. Anytime you see the line moving downward, you're going to have negative acceleration or deceleration, or a drop in velocity. The object is getting slower. And anytime you have a flat line, like you see there from B, C, D, E, or F to G, there is no acceleration. Velocity is staying constant. So, as I said, I will work through here with you on the first couple from A to B, B to C, and then you will finish up calculating the accelerations and describing the motion for the remaining changes in velocity. So, if you remember, acceleration is calculated by taking the final velocity, subtract the initial velocity, and divide that by the time of acceleration. So I'm just going to look at A and B here, and I can see I went from A to B. So my velocity increased from 0 to 20. 20 is my final velocity. Okay, so I'm going to take that number, that is my VF, and I'm going to subtract where I started from. I started at 0. 20 minus 0 happens to be 20. How long did it take to accelerate from A to B? It took 2 seconds. So I have 20 meters per second divided by 2 seconds. 20 divided by 2 is 10. And I am going to end up with 10 meters per second squared. That was my rate of acceleration from A to B. Okay, so what does that mean? That means that my velocity increased. Okay, my velocity increased. In other words, the object was speeding up. Now, when we get to B, we see that it flatlines from B to C. It stays at 20. This would be considered your initial velocity. C would be considered your final velocity. So 20 minus 20 is 0. Again, this happened from 2 seconds to 4 seconds, so a total acceleration of 2 seconds. Any number, or 0 divided by any number, is going to give you an acceleration of 0. There was no acceleration. So I simply would describe this as velocity was constant. Okay, so you're either telling me what you're going to do is do the remainder of these from C to D, D to E, and so on. You're going to calculate your acceleration from the graph, and then you're simply telling me what is happening to the velocity. Is the velocity increased? Does it stay constant? Or possibly, does it decrease? Okay, once you are finished calculating all these and describing the motion, you will see a place there in your module to submit this assignment. So something very easy to do. It just again is having you practice calculate accelerations and collecting data from a graph. Okay, so again, finish this up and get it turned in. And then have a great day.